morning. Good morning, FHS. Today is Wednesday, November 29th, 2023. Please join me in a minute of silence. Please stand if you are able and join me in the pledge. To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you for having me.
All right, good morning. First thing I need from you guys is to get out the book assignment we started on last class. That should be numbered as 53. I think we had about 30-40 minutes to start on it last time, and I did ask you to try to do 2 or 3 more questions for homework, to put eyes on a few more questions, and to hopefully get your brain to think about the process one more time. So if you would, go ahead and get out the book assignment and pick up where you left off. Give everybody just a minute here to get it out, and if you guys have any questions ready to go, I'm happy to start off with those. But today is mainly a practice day, so we need to aim to finish the book assignment first. And then once you're done with the book assignment, that is opened up in Google Classroom if you want to turn it in now and not have to worry about it. But then you should move on to the worksheet you picked up, 54, which is like a practice quiz. And that's going to be almost your last homework. These 2 are going to be almost your last homework assignments for the semester. I do give some participation points for finishing up the semester exam review, but short of that, your 5.3 quiz will count as a major grade, and your semester exam counts as a major grade if you're taking the semester exam. So. Last time, I think I took up some questions up through about question 15. You should have had plenty of time to ask up through 15 if you needed to. So, if you did above and beyond, or if you did at least 2 or 3 more questions like I suggested, and you found some that you got stuck on, go ahead and tell me what they are so that I can go ahead and get you past that point. Number what?
19.
Sure. So 19 looks like this, and they're actually trying to help you out here because this is already factored. Usually this type of question would look like this, and you would need to think about factoring out a GCF, but they've already done that for you. And then the reason why you do this in algebra so much is because if you have something times something equal to 0, this is a special property of 0 only. If I can make this be 0, then I don't care what this is, because 0 times anything gives me 0. Likewise, if I can make this be 0, I don't care what that is, because 0 times anything gives me 0. So that's why you set those factors equal to 0 and solve. And like we talked about in the notes last time, the major difference between solving an algebraic equation and solving a trig equation is really just the end of the question. And that would be, you are going to need unit circle every single time. So if you're rusty on that, as always, I would suggest just making a complete unit circle on a blank piece of paper and then checking it with your notes. Do that a couple times until you feel refreshed on that. But sine is going to be 0 here and here, the two places where y is 0, and also where sine is -1, which would be right here. So there's 3 places that are your answers. Now to finish and to actually write out the answer, you have to pay attention to the directions. If the directions say solve, your answer should look one way. If your answers say list the solutions between 0 and 2 pi, they should look another way. We did both ways on every single question on your note, so you should be able to do both, but you need to know which is which. This one just says solve, so that would imply also the coterminal solutions. So we could say x could be 0 plus everything coterminal, x could be pi plus all of his coterminal stuff, or x could even be 3 pi over 2. And anything coterminal to that. This would be fine and worth full credit on your quiz because it's technically correct. But that's not what the back of the book's going to look like, because these two are equidistant. These two are separated by pi radians. You can really condense these two into one statement. So when you check this in the back of the book, they're probably going to list the first one first, which would be 0. And then they're going to say, don't go all the way around, just add pi so you get this spot. And then if you continue adding pi, you start getting the coterminal angles. So this is equivalent to both of those. This one is not equidistant to either. So it's got to be its own statement. So you could either write it with these 3 or with those 2. Yes, yeah. Sure. Was that enough? Okay. Okay, so 21 looks like it actually starts on how I was saying on that last question, how you usually have to start them. They kind of did the first step for you on the last question. But I look at this and I immediately see that we've got a GCF. So I probably need to factor it out. This factors more, and typically when you need to factor, you want to factor completely. This is a difference of 2 squares. Cosine times cosine gives you cosine squared. 1 times 1 gives you 1. And difference of 2 squares always factors as a plus and a minus. So we can set this equal to 0, and some answers are going to come from that. We could set this equal to 0 and solve. We're going to get some more solutions from that. And we could set this equal to 0 and solve, and we'll get even more solutions. So anywhere where cosine is 0, 1, or -1 should make this original question true. So cosine is 0 in 2 places, -1 in 1 place, and +1 in 1 place. So there's 4 places where this is true. Kind of a sidebar here, but if you remember the first 2 questions in the assignment just talked about checking. If this was a question on your quiz and you were feeling kind of shaky and you weren't sure if those were the 4 right spots, Remember, you can check them. You can plug 0 into the original equation, make sure that it works. You could do the same thing with pi over 2, and then pi, and then 3 pi over 2. You can check to make sure those spots really were supposed to be your answers. So the long version would be to do 4 separate statements. So 0 plus 2 pi n, pi over 2 is the solution, plus 2 pi n, pi and everything coterminal to it, and even 3 pi over 2 and everything coterminal to it. So that is fine, but since all of these are equally spaced out, these are all spaced out by pi over 2, you could just do this in one statement. You could say start off at 0, and instead of going all the way around, just add pi over 2 each time. Of course, adding 0 doesn't do anything, so I wouldn't write that. This and this, either one of those would get you full credit. But again, this is one of those where you kind of see that it's kind of nice to know how to condense it, so you don't have to write out 4 statements. You can just write the one. Okay, is that enough for 21?
Yes, sir.
Okay. Is anybody else going to ask about 21? Have something more detailed? Okay. What else you got?
29.
29. Okay, so first thing I notice about 29 is the directions have changed. I should not be doing plus 2 pi n, plus 2 pi n, plus 2 pi n like I've done on the last several, because now I just want solutions between 0 and 2 pi. So my answer is going to look different. But this wants to know the sine of what angles take away 2 is the same as the cosine of what angles take away 2. Well, you could at least add 2 to both sides. That's going to simplify it some. And you're going to be left with sine is equal to cosine. Now this would be a question where I would say that it's probably a lot quicker to just go around the unit circle and think about everywhere where sine and cosine are equal instead of trying to do this algebraically. There's only 2 places where they're the same. At pi over 4, sine and cosine are exactly square root of 2 over 2. And at 5 pi over 4, they are both negative square root of 2 over 2. Those are the only 2 places that sine and cosine are the same. So we can take a little bit of a shortcut there and skip the algebra and just give these 2 spots. Now again, if you do this, it's going to be very unfortunate, but it usually happens to a person or two. If you do this on the quiz, this doesn't represent the directions. This would be good solutions if it just said solve. This says just list them out. List out the answers between 0 and 2 pi. So you should say pi over 4 and 5 pi over 4. Again, if you want to do it algebraically, go for it. It's just that the question is going to be pretty long, and you may create some extraneous solutions, so it is important that you check your answers. This way, I can feel pretty good about my process, so I don't feel like I have to check those. Okay, anybody else that's going to ask about 29, have something more on it before it goes away? Okay, then, I don't know, 1 or 2 more before I give you some time to do a couple more? Yeah.
Could you do 25?
Sure. 25. 2 cosine squared plus cosine minus 1 equals 0. Okay, so first thing I notice is, to me, this is like a quadratic. The biggest exponent is a 2, so I'm going to pretend like this is just a regular old quadratic equation. I'm sure I said this last time, but this is still a good strategy until you feel more comfortable. Remember that you are more than welcome out to the side, like I forced you to do on the notes. Everywhere there's a cosine x, just replace it with a regular x. sometimes making it look this way gives you a little bit more confidence on how to start. So this needs to be factored. This guy would factor as a 2x plus 1 and an x minus 1, which means that this is going to factor the same way, except that the x's are cosine x's. So 2 cosine x plus 1 times a cosine minus 1. Now that we've got factor times factor equals 0, I could set this factor equal to 0 and solve. I could set this factor equal to 0 and solve. And that's going to tell me where my answers are supposed to land. So all my answers should come from when cosine is 1, cosine is negative 1/2, and there's 2 places where cosine is negative 1/2 and 1 place where cosine is 1. So since the directions say solve, I need the plus 2 pi n stuff. So you could do this in 3 statements, since there's 3 spots. Or, yeah.
I think you factored it wrong. I think you have to switch the plus and minus.
Oh, you're right. I did factor it wrong. I should have been more careful. This should be a minus, this should be a plus, which means this should be a plus and this should be a minus. So that does make a difference. Luckily not too much. Thank you for catching that. So when cosine's positive 1/2 and negative 1. Okay, so it's not these 3 spots. It was pi over 3, pi, and 5 pi over 3. Okay, or you could still condense these into 1 as well, because these are all equidistant. They go from 1 pi over 3 to pi. You could add 2 pi over 3. And then they go from pi to 5 pi over 3. That's adding 2 pi over 3 again. And then if you added 2 pi over 3 a third time, you land in the original spot. So then every time you keep adding 2 pi over 3, you start getting all the coterminal angles. So you could just list the first one, pi over 3, plus 2 pi thirds n. This one statement means the same thing as those 3 statements, whichever way you prefer. So even though I saw to factor that one pretty quickly, of course, be careful that you factored it correctly. Notice how I didn't struggle with that question. I was almost done and I was almost ready to move on, and just the signs on factoring almost made me have completely wrong answers. So that's why even if you feel confident, you should, on a quiz, check your answers by plugging them in. If I tried to plug in 0 into this, I would have gotten 2 plus 1 minus 1 equals 0, and that doesn't make sense. That would be 2, not 0. So 0 couldn't have been a solution. I still could have caught that if I had checked my work. Okay, Luke, is that enough for that? Okay. Was anybody else going to ask about 25? Need to ask while it's up. Okay. Again, I'm not going to push this on every single question, but I do think that this is a very valid strategy. Change all the trig functions to x's, and then force yourself to think about how to start this, because this is going to start off the same way. These questions should not be any harder to start. Doesn't mean that they're always going to be easy algebra to solve. It doesn't mean that the unit circle part is going to be easy. Knowing how to write your answers is important, but the logic behind the first half of the question and solving should be no different than you've done in past courses. So, okay, we got any more ready to go? No, what you got?
Go over 27.
27? Sure. Okay, so when I glance at 27, Again, to me, this looks like a quadratic because it's got an exponent of 2. And I know that when I solve a quadratic, I would always like to put everything on one side set equal to 0. Again, if you wrote it with just x's, it looks like that. Moving this over makes it look like this. It's pretty obvious to factor this guy. This is going to factor the same way. This factors as an x minus 2 and an x plus 1. So this should factor as a secant x minus 2 and a secant x plus 1. And I'm going to double check my factoring since I almost messed it up last time. Unlike an algebra problem where you set this equal to 0 and solve, and set this equal to 0 and solve and you're done, you still need to set this equal to 0 and solve, set this equal to 0 and solve, and then your solutions are supposed to come from the unit circle. Most people don't memorize secant values, so what you can do is take the reciprocal of both sides. A reciprocal of -1 is still -1. And now really the bulk of what's new about this is making sure that you can locate these values on the unit circle. And know what your answer should look like based on the directions. This one says solve, so I need all the coterminal spots too. So as 3 statements, this would be pi over 3 plus 2 pi n, pi plus 2 pi n, and 5 pi over 3 plus 2 pi n. Or, this might even be the same setup, but or as one statement, you could list the first spot, pi over 3. See that you have to add 2 pi thirds, add 2 pi thirds, add 2 pi thirds. Since all of these are equidistant, instead of going all the way around plus 2 pi n, you could just add 2 pi thirds each time. So that's why the back of the book should probably look like this. I think they always condense if they can. I'm not sure. Okay, something more specific than that? Did you get what you needed? Okay. Aiden, is that your question or do you have something else? Okay, so you were not supposed to come to class with this finished, so I know that you've got some more questions to do and you may not know which ones to ask yet. So let me give you 10 or 15 minutes to try to do 2 or 3 questions, and then I will interrupt again and take as many questions as you had time to find.
Bless you. Bless you. Bless you. Bless you.
more minutes and I'll take another round of questions. I am ready for another round of questions. So, anything you tried and need some help with in those 15 minutes?
You did number 37.
Sure, 37. Let's see, 37, cosecant of what angle plus the cotangent of the same angle has to equal 1. Okay, so unfortunately these are like two different variables, so it's kind of hard to move forward with normal algebra stuff. In algebra, if you have two different variables, you can't solve a single equation. But because these things are related in some way or another, I can try to make this look different. So for example, I know this is the same as 1 over sine, so I could try to make it look like that. And this guy is the same as cosine over sine, so I could try to make that change. And I don't know if this is going to get me anywhere, but they do have a common denominator already, so it would be easy to add these fractions together. And then finally, if we multiply both sides by sine, that's an improvement because now I don't have fractions. This looks like one of the last type of questions we looked at in your notes. If it's saying add 1 to cosine to get sine, there's only 4 spots on the unit circle. I don't have to rely on algebra anymore here. There's only 4 spots on the unit circle where sine and cosine are separated by 1. That is all of these angles in between the quadrants. Those are called quadrantal angles. So I can just guess and check those 4 spots. Cosine's the x values on the unit circle, sine's the y values. So anytime I could add 1 to x and I get y, that's going to be a solution spot. So if I add 1 to x here, that would be 2. That does not equal y, which is 0. If I add 1 to x, it does equal y. So adding 1 to cosine does give me sine. So pi over 2 is a solution. Here, if I add 1 to cosine, it makes it 0, which is equal to sine, also 0. So this also should be meeting those requirements at pi. And the only other one that's exactly spaced out by 1, like this is saying, is 3 pi over 2. But if I add 1 to cosine, that makes it 1. Sine is -1. Those are not equal like it's supposed to be. So, based on the directions, I don't need the plus 2 pi n stuff, so I should be able to quit there. Now again, I'm going to kind of pull back and talk about the checking that we did in the first 2 questions, because I just want you all to see it really doesn't take that much work to check your answers. If I was checking, and it's obviously a lot quicker if I don't have to write it down, but if I was checking pi over 2 and I plug that in here or here, same thing, the sine at pi over 2 is 1. The cosine at pi over 2 is 0. Sine over pi over 2 is 1. 0 divided by 1 is 0. And 1 plus 0 equals 1. So I have that quickly confirmed that pi over 2 solves the original equation. I can also check pi. Plug in pi here. Oh, that one would not work, would it? It's a good thing that I checked. This must have been an extraneous solution. When we multiplied both sides by sine here, there were some solutions that were undefined, and then when I wrote it like this, it was hard to see them. If you try pi and you plug in 0 here or 0 here, you're going to get undefined on this part. 1 divided by 0 is not possible. So this was extraneous, so it should not be part of our solution. So I would just stick with pi over 2. And I kind of like to look to see if they went that in depth with it in the back. No. Yeah, they did. They just got pi over 2 also. That's one of the things, it's hard for y'all to know, like there's not just a list of math things I can say, when you do this, you always need to check for extraneous answers. Just in theory, you should always want to check your work. You don't have to check your work this way on every single book question because you have other methods to check. But you guys can see that like some of these algebra processes, like multiplying both sides by sine, created an answer that looked like it solved this, but it didn't solve the original thing. That pi could not have ever been an answer because pi doesn't exist for this or this. Both of those make you divide by 0. And you're just not even going to think about that without checking your answers. So, okay, anything more specific about 37? Okay. Another question or two? Yeah, go. No, she raised her hand first. What you got?
39.
39? Okay, 39 is different because it's one that has a number next to x. It's not just a 1x, this is a 2x. So that's going to add a couple steps to our work here, but the first few steps should still be the same. Undo a -1 with the +1. Undo a ×2 with the divide by 2. And then the way we talked about this in the notes last time is pretend like this is just an x for just a moment and think about where cosine is 1/2. That would be at pi over 3 and everything coterminal to it, and also 5 pi over 3. And everything coterminal to that. The only thing you have to do in addition to these questions is to catch yourself and say, wait a second, I didn't really solve for x, I solved for 2x. So, to make this go from 2x equals to 1x equals, I need to divide everything by 2. And then same thing with this one, divide everything by 2. And then it just depends on what the directions say. This question said solve, so I can quit there. You pretty much just solve it the same way and then divide everything by 2 because there is a 2 next to the x. Or you solve everything and divide everything by 3 if there's a 3 next to the x. Or solve it normally and multiply everything by 2 if there's a 1/2 next to the x. Really just adds one extra step there. Okay, Jackson, was that the question you had or was it something different?
Something different.
Okay, which one did you have?
35,
35?
45.
Oh, 45. Okay, so similar to the last question type, but this one has a tangent, which is going to make the unit circle part potentially more difficult. But again, you can start off with basic arithmetic, undo, subtract, by adding, undo timesing by dividing. And there's really nothing else I can do at this point, so I'm going to pretend like this is a regular old x for a minute, just to help me get my feet on the ground. And if it was an x, tangent would be positive square root of 3 over 3. Always square root of 3 over 3 near the x-axis, positive in 1 and 3. So this is where I'm saving some time because I memorized the tangent values. There's only 3 of them and you have to be worried about signs, but if you don't, you're going to have to do some more investigation to find those spots. So without much more thinking, I'm going to say, well, pi over 6 is an answer spot. So pi over 6 and everything coterminal. Also 7 pi over 6 and everything coterminal. And then the only thing that's different is you have to realize that we did not solve for x. We have solved for 1/2 x. X over 2 is the same thing as 1/2 times x. So to make this go from 1/2 x equals to just x equals, I would like to multiply this by 2, which means everything gets multiplied by 2. Do the same thing with this one. Multiply everything by 2. So I don't need to do that. And then that would be your final answers because it says solve. Okay, is that enough for 45? Yeah. 29? Sure. We already did 29 earlier. I'll put it back up for a second. Or it'll be on the class recording later. But I'll leave it up for a second while people keep looking. Okay, yeah. I'm sorry. 49? Sure. Okay, 49 is quite a bit different and not really something you need to probably worry about for our quiz, because our quiz should be no calculator. This is just a calculator practice question, and so I don't know. I could see why you might want to be dismissive of it, knowing that it's not going to be a part of your quiz. But I can also tell y'all that in calculus, a big part of what holds students back is not being comfortable and familiar with the calculators and being able to do stuff quickly on the calculator. The AP Calculus exam, half of the points come from calculator stuff and half of them come from no calculator stuff. And it doesn't matter if you know the calculus if you don't know how to work your calculator. There's going to be lots of calculator type questions you can't do. Okay, so if I just started trying to solve this by hand, I could subtract a 2 and divide a 5. The reason why this is not a great question to do by hand is sine does exist here. Sine picks up every value from -1 to 1, and -2/5 is between that. But it's not a spot that I memorize. It's not a ratio that I memorize on the unit circle. So I don't know how big that angle is. It exists, I just don't memorize it. But they said we can use a calculator to approximate this to 3 decimal places between 0 and 2 pi. So you would, in your calculator, want to graph the left side of your equation and the right side of your equation, probably as separate lines. This is not the only way to do this, but I'm going to put my calculator in radian mode because in the directions it says find the solutions between 0 and 2 pi. So I want my x values to go from 0 to 2 pi. I don't want to look at more of the graph than is really part of my answer. So the blue line represents sine x, the red line represents -2/5. So those are going to be equal when they're in the same place at the same time. I can see that there's 2 times where this happens, and to find these locations you can do trace to get pretty close, but this is not good enough in calculus. You have to get within 3 decimal places. So there's a menu, second trace. We'll talk about this a lot more second semester, but your calculator can do these operations pretty easily. I'm going to want intersect because I want it to tell me when these lines intersect. So hit enter to identify the first curve, hit enter to identify the second curve. You can try to make a guess or just hit enter to skip it, and then your calculator will bounce that point back and forth until they're at the same place at the same time. So they are both at -2/5 when x is 3.553. X is about 3.553, and I saw there was a second one. There's a second one over here, so I have to move my cursor over here for it to know which one I'm asking it to find and go through the same steps again. Second trace, find an intersection, move your cursor a little bit closer to it so it knows which one you want it to find. Hit enter to identify the first curve, hit enter to identify the second curve, and hit enter to skip guess. Then your calculator will bounce that point back and forth until it finds the intersection. They are both -2/5 when x is about 5.872. When x is about 5.872. So, rounded to the nearest 3 decimal places. That's what it wanted. So again, not anything you need to stress out about or study, but it is something you need to know. Any follow-up to that one for anybody? I'm assuming you guys have used these before, right? The second trace, you use some of that in Algebra 2? Okay. The big ones, 0 is super important, intersect, I don't know, I just used it, so it's pretty good. Min and max is also pretty helpful. Some of this other stuff is calculus stuff, but sometimes even knowing those calculator tricks can help you on the ACT, stuff that you could do by hand, but sometimes you have an option as a way to do it much faster if you know what your calculator is capable of doing. Okay, let's go with, try to do 1 or 2 more before I reset our timer.
Can you do 43?
43? All right, for 43, so this is one of the multi-angle questions. What makes it multi-angle is it's not cosine of x, it's cosine of some number times x, in this case 1/2 times x. So we can still start it off the same way by undoing subtraction. Oops. Undoing multiplication, and we get to here. And then temporarily pretend like it's not a 1/2 x, pretend like it's a 1x, and work it this way. So cosine is positive square root of 2 over 2 here and there. So the directions want me to solve, so I'm tempted to say I've got an answer at pi over 4 plus everything coterminal to it, and 7 pi over 4 plus everything coterminal to it. But before you circle that as your answer, you have to remember that we never really solved for x, we solved for 1/2 x. I wrote it as x as a convenient way to help me start this, but right here I don't know what x equals. I know what 1/2 x equals. So I can take this equation, multiply everything by 2, and now it's in terms of x equals, and then do the same thing with this one. Multiply everything by 2. Now I really know what x is equal to. And since the directions just say solve, and don't say give the solutions between 0 and 2 pi, this is the way it wants me to write my answer. So that 1/2 really just adds one extra step, but you have to remember to do it at the end. Is that good? All right. All right, still got about 35 minutes, so let me give you another 10-15 minute timer to try to get a couple more done. Those of you that are finishing up the book work, you need to move on to the worksheet. You don't have to have the worksheet done when you come to class next time, but that is your practice quiz, and next class will be your last chance to kind of fill in the gaps. So you really kind of need to know what type of things you may be expected to do on the quiz that you don't know how to do. As I mentioned on Monday, this is a B week, so I will not see you again until next Monday, which puts our 5.3 quiz this time next week. So lots of calendar time, but as you guys can see, these take a little bit of practice before they start to feel easier. What's up?
Can't hear my way.
Okay, sounds good. Yep. All right, guys, we're down to about 20 minutes here, and our 15-minute timer is up. So let me give you another chance to try to finish up the book questions. So any others that you would like? Go ahead.
You already did 23.
23. I don't think I did. All right, so 23. 3 times tangent. Actually, maybe I did, but I said I didn't. So I went ahead and I'm going to subtract that tangent over because then I can see if both of these terms have a tangent. I can factor out a tangent as GCF. Then I can set this equal to 0. So anywhere where tangent is 0. So you may want to think of tangent as sine over cosine. Tangent's going to be 0 when sine is 0. And then this part's a little bit messier, but we could add the 1, divide the 3. To get rid of the square, you've got to do square root, which, as we talked about in the notes, I'm concerned you will forget the plus or minus. That's a big thing. And yesterday I remembered that in a question and then I forgot it a few steps later, so I'm guilty of that sometimes as well. And before this looks familiar to where I would know where this occurs on the unit circle, I'm going to need to take the square root of my fraction and rationalize it before it looks familiar. But plus or minus square root of 3 over 3. So all the values near the x-axis. So there are 6 places this occurs. So this is where you would really probably appreciate the condensing. So, but if you don't condense, you could say 0 plus 2 pi n and pi plus 2 pi n from that factor. And then from these, it could be pi over 6 and the coterminals, and 5 pi over 6 and the coterminals, and 7 pi over 6 and the coterminals, and 11 pi over 6 and the coterminals. So that is without condensing anything, but mathematically that is the case. All of those equations give us solutions for x. Or the condensing, we could get away with 3 statements. I could get both of these, because both of these are spaced out by pi. So I could say, starting at 0, just add pi in. So this is equivalent to both of those. Over here, I could get pi over 6 and 7 pi over 6 because they are both spaced out by pi. Those two are evenly spaced. So I could say, starting at pi over 6, just add pi in. And this statement could replace both of those. It's occurring twice as often, which is why I need half as many statements. And finally, these two could be condensed. So I could say 5 pi over 6 is the first one, and add pi, and this statement would account for both of those. So personally, I would aim for these 3 on the right and not even write out this mess, but they're saying the same thing. Okay, let me pull it back up here. Did that get you past where you needed? Okay. Okay, and then Luke, was that you that had something else?
Yeah, 35.
35. Let's see. So 2 times the sine of what? Plus the cosecant. Same angle would be 0. Okay, so again, 2 trig functions. So you have to treat this almost like two different variables, like an x and a y. So I don't see any normal algebra stuff I could do. I can't just undo adding or subtracting. I can't just undo multiply or divide. But I guess I could try to think of this, and I don't know if this is going to help or not, but I don't know what else to try. I could change that to 1 over sine, and then maybe I would consider multiplying everything by sine. Multiplying everything by sine gets rid of my fractions, and now it doesn't look too scary. Although right here, multiplying everything by sine, I may have created some extraneous solutions, so I will have to, not just a good idea, but I will have to check my answer at the end. Okay, now it looks a little more normal. Subtract the 1, divide the 2. Okay, maybe it's not so normal. You take the square root of both sides. To get rid of the square, you need plus or minus. But it looks like we come to a problem here. The square root of a negative number, this is how we get imaginary solutions. Imaginary numbers certainly exist, but we are working with the real numbers. We're not messing with imaginary numbers in here. So if the only place where you think about the unit circle, nowhere on the unit circle do you have I, or imaginary ratios. So nowhere on the unit circle is going to have imaginary solutions. So I would, unless it's something I'm not thinking of, I'm going to just say no solutions are not possible. But let me double check before I call it quits. Yeah, that's correct. No solution. So imaginary numbers exist. It's just that we are not working with imaginary numbers. So. Okay, is there anybody who has not asked a question today? I'll give you a chance before I let anybody else try to squeeze in 1 or 2 more. Yeah, sorry. 33? Okay, 33 is a good one to ask because I kind of warned you about this in the notes, but then there's not much practice on these. So again, sine and cosine are totally different things. So this is almost like an x and a y, 2 different variables. So just like this last question, I tried to think of a way to rewrite cosecant so I could at least move forward. Here, you're never going to solve this if you leave sine squareds and cosine squareds in there. At some point, you're going to have to remember that the first Pythagorean identity is a way to relate sine squareds to cosine squareds. And so I could either replace sine squared with 1 minus cosine squared, or I could replace cosine squared with 1 minus sine squared. Just whichever is going to look easier to me is what you should roll with. I'm going to go with this one. I'm not really sure which would be easier, if there is a difference. But you need to see why making this substitution is a lot more comfortable. Now it's only cosine stuff, so now it doesn't have that trick to the question. We can add this over. We can divide both sides by 4. We can square root both sides. Don't forget plus or minus. The square root of a fraction is like square rooting the numerator over square rooting the denominator. Both of those simplify. And so it looks like our solutions should come from everywhere where cosine is plus or minus 1/2. And the directions just want me to give the solutions between 0 and 2 pi, so I really just need to name these angles. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All of those should be solutions. But that is and I don't know if it's on this year's quiz. I'm not in charge of putting this year's quiz on there, but usually one of the questions on the quiz requires you to make this type of substitution. That's a big part of why we worked with those earlier this year, which is why I put it on your notes as well. Okay, is that enough?
Yes.
Okay, yeah. Sure. Okay, so same kind of idea. This one started off with sines and cosine stuff, so I rewrote one of them so that it was only cosines. And in did you say 31?
Yes, sir.
Okay, so same thing with this. I've got some sine squareds and I've got some cosines. So that's going to be a problem, and I'm going to have to fix that at some point. I can't just replace cosine with sines. Cosine is not equal to 1 minus sine. Just like Pythagorean theorem, the things have to be squared. The first Pythagorean identities have to be squared. But I could say sine squared is the same thing as 1 minus cosine squared. So if I make that replacement right here, instead of saying sine squared, let's do 1 minus cosine squared. And to me, that looks like an improvement because now I only have cosine stuff, so I don't have the same issue of things being mixed up. So we could distribute the 2. To me, this looks like a quadratic because the biggest exponent is a 2. So I'm going to get everything on one side set equal to 0. Add this over. Add this over. And then most quadratics can solve with factoring. Though I don't know if this one does. Could be 2x and x. Did you make it this far?
Should those twos cancel out or might not be?
Oh, yeah, that would probably help. If I subtracted this over, that doesn't become a 4, that should become a 0. And that makes the factoring a lot easier. I mean, the thing is, not all quadratics have to factor, so in theory you can do quadratic formula even with cosines instead of x's. I just didn't think it was going to get into that. That's the only reason I was hesitating. But okay, so now both of these have a cosine. Thank you for catching that for me. So I can do a GCF. Set each factor equal to 0 and solve. Looks like our answer should come from when cosine is 0 and when cosine is -1/2. So based on its directions, my answer should be a pi over 2, 2 pi over 3, 4 pi over 3, and a 3 pi over 2. All of those should work. And again, I'm going to plug one more time since this is going to be the last one we have questions for or time for today. But if you did this on the quiz and if you had extra time, remember you can quickly check one of these. Just try plugging it into the original problem. The sine at pi over 2 is 1. The cosine at pi over 2 is 0. You end up with 2 on the left, 2 on the right of the original problem. And in about those 5 or 10 seconds, I can confirm pi over 2 works. And then, of course, if I had time, I could check the rest to know if I needed to spend more time on this. Okay, we do need to find a stopping place here. So if you finished up 53, again, that is opened up in Google Classroom, so I always encourage you to go ahead and turn it in case you lose it. And you guys know, if I get an opportunity to try to grade them early, I do. And if it doesn't look like you're going to get full credit, I try to let you know so you get a chance to fix it before it's due. And then please try to do some, if not most, of the practice quiz for the next class. We'll be able to finish that and get all your questions answered. Our next class is Monday, and that will be your last chance to get help in section 5.3.